Good afternoon, friends. Today we are going to study physics. Okay, and the topic for today is heat capacity. Now, we have some questions in our exercise books, physics, chemistry, and also math. And I discovered that some of my students have problem understanding how to solve this kind of questions. So I decided to bring these questions in my YouTube channel in order to uh, give them more chance. They can repeat it again and again, watch it again and again until they fully understand how to solve this kind of questions, how to work out this kind of questions. Okay, this first question on board here. I read the question and then we discuss together, okay? Number one, calculate the specific heat capacity of a substance if 385,000 joule of energy is needed to heat a mass of 5 kg, 5 kilogram of the substance from 30 degrees Celsius to 80 degrees Celsius. I want to make sure that the question is right. Yeah. Okay, I repeat one more time. Calculate the specific heat capacity of a substance if 385,000 joule of energy is needed to heat a mass of 5 kilogram of the substance from 30 degrees Celsius to 80 degrees Celsius. Now, before we answer these questions, before we solve this problem, we need to write down what we know in order to help us discover what we do not know. So what we write here, what we know, our energy here, energy, so we call this energy needed, energy required. In physics, we call this calorie, okay? Calorie, energy consumption. So we put Q, we give letter Q here. So Q equals 385,000 joule, okay? 385,000 joule. And what else we know? Mass, okay? So we give M here. M is 5 kg, okay? 5 kg. And what else we know? Okay, 30 degrees Celsius. 30 degrees Celsius is the temperature in which the heating process starts. Okay, one more time. 30 degrees Celsius is the temperature in which the heating process of the substance starts. So we call this as our initial temperature. Okay, so we put here T1. So T1 is 30 degrees Celsius. And we have 80, so 30 to 80. Now, 80 degrees Celsius is the final temperature when the heating process ends at 80 degrees Celsius. So 80 degrees Celsius is our final temperature. We name it T2. Okay, T2 equals 80 degrees Celsius. Okay. Now the question wants us to find the specific heat capacity. Okay, specific heat capacity. We have written down all what we know from this question. Now all what we know here will enable us to answer these questions. So we will find out specific heat capacity, okay? Calculate the specific heat capacity. Now we need to select a proper formula to help us work out this question. So we put here C, because we know C is the specific heat capacity, okay? So C equals Q over M times delta T. Okay, this is the formula we are going to use. C equals, or heat capacity, okay, equals Q, okay, Q is the energy consumption, okay, Q is the energy consumption or energy needed or energy required to do the heating process here, over mass. We have 5 kg here, and then delta T is the temperature. Okay, delta T is the temperature. So we continue on this. Let's continue on this. Q is 385,000, okay? 385,000 joule, okay? 385,000 joule. So we put equals here. Over M. M is mass. We have it here, 5 kg, okay? We put here 5 kg. We need to put the unit as well. Times delta T, okay? Now, we need to work out delta T. We don't have delta T here, but we have initial temperature and the final temperature. So, we want to find out delta T. So, how to find out delta T? We see here, delta T equals T2 minus T1, okay? T2 minus T1. Now, this, we have T2 is 80 degrees Celsius, 80 degrees Celsius minus 30 degrees Celsius, 30 degrees Celsius. So we bring up it here. Delta T equals T2 minus T1, okay? So we have here 80 minus 30, okay? Both degrees Celsius. So delta T equals 50, okay? There is 50 between 80 and 30. So delta T equals 50 degrees, 50, what am I doing? 50 degrees Celsius. Okay, delta T is 50 degrees Celsius. 50 degrees Celsius. I hope that's big enough so everybody can see it. Okay, so our delta T here is 50 degrees Celsius. We need to write the unit as well, okay? In physics, it's important. Now we put here. So we bring that down. 385,000 joule over. Now we multiply this. 5 and 50. 5 times 5 is 25. So 250. 250. We put kg here. Kg and degrees Celsius as well. Degrees Celsius. Okay? 250 kg degrees Celsius. Okay. What we have here, we need to use our calculator. Okay? We use our calculator to make it faster. Okay? 385,000. 385,000 over 250. Okay? We got 1,540. Okay? 1,540. So we put here 1,540. Now, joule we bring here. We just bring it straight here. And the kg is denominator. So we bring up here. Okay? Now look here. This is power 1. So kg power 1 here. When we bring up here, it becomes minus 1. And degrees Celsius is also denominator here. We bring up there, becomes degrees Celsius power minus 1. Okay? Degrees Celsius power minus 1. So we have, I think I need to bring it. I'm afraid that you won't be able to see it. So I need to bring it closer to here. So we put here. So it is 1,540. 1,540 joule kg power minus 1 degrees Celsius power minus 1. Okay, degrees Celsius power minus 1. So this is our answer. So C equals 1,540 joule kg, kilogram power minus 1, degrees Celsius power minus 1. Okay, let's go through this one more time. And then we erase and we bring one more. Okay, calculate the specific heat capacity of a substance. The substance name is not mentioned in here. If 385,000 joule of energy is needed or required to heat a mass of 5 kg of the substance from 30 degrees Celsius to 80 degrees Celsius. Okay, as I said before, to answer this question, we need to see what we know from this question. Okay, what do we know from this question? We have the energy consumption, which we call calorie. Okay, this 385,000 joule is the energy consumption or energy needed, energy required. So normally we name it Q for calorie. Okay, Q equals 385,000 joule. Okay, the unit is joule. And then mass here, 5 kilogram here, it's there. So we name it mass. Okay, M with letter M here. M equals 5 kg. And 30 degrees Celsius is the heating process starts from here. Okay, the heating process starts from 30 degrees Celsius. Now this we call as our initial temperature. So we call it T1. We write as T1 here, 30 degrees Celsius. And the 80 degrees Celsius is the final temperature. This is the temperature when the heating process ends. Okay, so we call it our final temperature. We put it T2. Now we have written everything we know. Now the formula, suitable formula to answer this question, okay, to solve this question is C equals Q over M times delta T. Okay, C is for the capacity, okay, heat capacity. So we put it here, C equals Q over M times delta T. Now Q, 385,000 joule, it's here, and M is 5 kg here, and delta T, we work it out here. We find delta T from initial temperature and final temperature. So delta T equals T2 minus T1, which is 80 degrees Celsius minus 30 degrees Celsius. So we got 50 degrees Celsius. So we put it there. Okay. And we bring it here, 385,000 joule divided by 250. We multiply this. 5 times 50 is 250, okay? 250 kg and Celsius. So 250 kilogram degrees Celsius. Now, we define this 385,000 divided by 250, we get 1,540. So this joule we bring straight here, and kg we bring up there. So kg here, power 1, we bring up here, becomes power minus 1. Degrees Celsius as well. Degrees Celsius, power 1 here, we bring up there, becomes power minus 1. Okay? So that's the answer for this question. Question number 1. Now I'm going to erase this question. Okay? I erase this question and we bring one more. Okay? You can always go back, watch it again and again until you fully understand how to work out this question and see the formula. Okay? We use proper suitable formula to answer these questions, and you need to know, you need to write down what you know from the question in order to enable you to answer the question. Okay, I erase and we bring one more. Okay, we will look at question number 2, okay? So we put question 2 here, number 2, okay? The question is here. It says calculate the energy needed to heat, the energy needed or required, okay, needed to heat to heat 8 kilogram of water, 8 kilogram of water from room temperature. Room temperature it's 25. So I put 25 degrees Celsius here. Okay, 25 degrees Celsius. Okay, 25 degrees Celsius. So from 25 degrees Celsius to 100 degrees Celsius. 100 degrees Celsius. Okay. The specific heat capacity of water. Heat capacity of water. Heat capacity of water. Specific heat capacity of water is 4,200. 4,200 joule kg power minus 1 degrees Celsius power minus 1. Okay, so I hope this question we have got everything. Calculate the energy needed to heat 8 kg. The energy needed to heat 8 kg of water from room temperature. Water from room temperature 25 degrees Celsius. 25 degrees Celsius to 100 degrees Celsius. The specific heat capacity of water is 4,200 joule kg power minus 1 degrees Celsius power minus 1. Okay, we are going to see this question. We see first what we know from this question, okay? First of all, we need to write down what we know from this question. We have initial temperature there. So T1 equals 25 degrees Celsius. Okay, 25 degrees Celsius. T2 equals 100 degrees Celsius. What else we have? Mass 8 kg here. Mass is 8 kg, and heat capacity of water, so we give it C, is 4,200. 4,200. J, kg power minus 1 degrees Celsius power minus 1. 4,200 is correct. 4,200, yeah. Okay, 4,200. Now, we look here, friends, the heat capacity of water is high, okay, is very high. 4,200 is big number, okay. So energy needed for this should be big. We will find it out, okay. We will find it out. Now, we have written everything that we know from this question. Our initial temperature, okay, initial temperature is 25 degrees Celsius, which we write as T1, okay, T1 is 25 degrees Celsius, and the final temperature is 100 degrees Celsius. So it's here, and the mass is 8 kg, it's there, okay, 8 kilogram, and the heat capacity, this one here, 4,000, the specific heat capacity of water, so this is 4,200 joule kg power minus 1 degrees Celsius power minus 1. Now our formula is C equals Q over M times delta T. Okay, this is the formula we used when we answered the first question. Now this question is different. This question does not ask us to find the heat capacity, because heat capacity is already mentioned here, but they want us to find the energy needed, okay, energy consumption or calorie. So we need to convert this formula, okay, to this question, okay? So we convert it. Let's convert. So C equals Q over M times delta T. Now they ask for energy needed or energy consumption or the calorie. So we take the Q out here. So we put Q here. Q equals. Now we take Q to be the subject. We bring C in. So Q equals C times M times delta T. Okay? C times M times delta T. You can just put dot like that. That's no problem. Okay? You can do that. We can do it. Okay? We can do like this. So C dot M dot delta T. Okay, no problem. You can do that. Okay. All right. Now we see here what we have. We can put here. We just put here. Okay. So we put here. So Q. Okay. Q equals, now C, we have C here. 4,200 joule kg power minus 1 degrees Celsius power minus 1. Okay? Times, so we put times there, mass, okay, M 8 kg times 8 kg times delta T. Now, delta T, once again, we have to work it out. Okay? We need to work this out. To find delta T, we use our initial temperature, T1, and our final temperature. So, delta T, we put here, delta T equals T2 minus T1. Okay? T2 minus T1. T2 is 100 degrees Celsius minus T1 is 25 degrees Celsius. So this is 75 degrees Celsius. So delta T equals 75 degrees Celsius. So we put here times 75 degrees Celsius. Okay. We continue here. Now, before we multiply the numbers here, we have 4,200, we have 8, we have 75. We look at the units we have in here. We have 4,200 joule kg power minus 1 degree Celsius power minus 1 times, okay, times 8 kg is power 1, but we don't write it, times 75 degrees power 1 also, we don't write it. Now, we look at the units here. We have in algebra, okay? I'm sure you understand algebra, okay? In algebra, when we multiply things like this, okay? We multiply numbers, things like this. The power, we add, okay? Or we add the powers. Now, we look here, kg is power minus 1, okay? This kg here, power minus 1. Kg here, power 1. So, minus 1 and 1 are gone, okay? So, we cancel this. Cancel. We cross them out. Kg power 1, kg power minus 1 and kg power 1 are out. They cancel one another. Now, we look at the next unit. In here, we have degree Celsius power minus 1, okay? Degree Celsius power minus 1 here. And here, we have degree Celsius power 1. We don't write it, but it's 1. So, degree Celsius power minus 1 and degree Celsius power 1, we add this power, they also cancel one another. So, we cross this out. Now, what we have left here is joule, okay? Only joule. So, let's multiply this, use our calculator to make it faster. So, 4,200 times 8 times 75. We get 2,520,000. Okay, 2,520,000 joule. So Q equals Q equals 2,520,000 joule. Whoa, what a number. It's a very big number. 2,520,000 joule. Then you might ask question, why the number is so big like this? Okay, friends, I want to tell you, when you study chemistry or physics, okay, you discover that different substances have different heat capacity. Okay, the substance we are talking here is water. The heat capacity of water is high. We look here, is 4,200 joule kg power minus 1 degrees Celsius power minus 1. It's high. That's why it takes longer time to heat water from 25 degrees Celsius to reach the boiling point. 100 degrees Celsius is the boiling point of water. It's here. Okay? It takes big amount of energy, 2,520,000 calories. Okay? Or joule in this case, joule. It's very big. If we compare water to solids such as iron or copper, it's very big. The difference is very big. Copper is very low. Heat capacity of copper is very low. Copper is very important in our daily life. If you peel out the rubber of your mobile phone charger or electric wire, you discover that the inside, okay, wire inside, you see the color is brownish, yellow brownish. If you check your the pipe of your hot water, okay, hot water pipe, you discover that the color is also like yellow brownish. And hot water container, why all this yellow brownish? Why not silvery or white or something? They use copper because copper is very good heat conductor and electricity conductor as well. Electric conductor. Copper is very good. The best one is diamond. Okay, diamond is better than copper, but diamond is extremely expensive. Can you imagine if we use diamond to make our electric wire, to make your mobile phone charger, to make hot water pipes or container? Oh, it's very expensive. But copper is very good. It's very, very good. And it is abundance, okay? We can also get it with a cheaper price. So copper is very good. We see here water heat capacity is high, okay? We have here 4,200, okay? Joule kg power minus 1 degrees Celsius power 1. So that is why big amount of energy is needed, okay? Big amount of energy, calorie is needed. 2,520,000 to heat this 8 kilogram of water from starting temperature is 25 to reach the boiling point 100 degrees Celsius. So let's go through this question one more time and then I let you go, okay? So the question says, calculate the energy needed. So this clearly you need to think of the Q, okay? Calorie, energy consumption, okay? Energy needed, energy required. Calculate the energy needed to heat 8 kilogram of water. This mesh is 8 kilogram of water from room temperature, this 25 degrees Celsius, to the boiling point. Okay, boiling point of water is 100 degrees Celsius. The specific heat capacity of water is given here, 4,200 kg power minus 1 degrees Celsius power minus 1. So first of all, before you answer these questions, you need to write down all what you know from the questions in order to enable you discover what you need to find out. So our initial temperature is, this is initial temperature, 25 degrees Celsius. It is the temperature when the heating process starts. And the heating process ends with the final temperature 100 degrees Celsius. We name it T2. So T1 25 degrees Celsius, T2 100 degrees Celsius. Now, mesh here, our mesh is 8 kg. Okay, 8 kg. So 8 kilogram. We put M here, 8 kilogram. And then heat capacity, this is heat capacity here, is 4,200. Okay, so we put here 4,200. And delta T, the formula, suitable formula to use is this one here. This is our formula, C equals Q over M times delta T. Now, in this question, ask for Q. So we need to convert the formula in order to suit these questions. So we convert it, we take the Q to be the subject here, we put here, and we bring C in. So Q equals C times M times delta T. Okay, we work out delta T with our initial temperature and our final temperature. So we put here, our C is, okay, this heat capacity is 4,200 joule kg power minus 1 degree Celsius power minus 1 times 8 kg, this is the mass, and the delta T is 75 degrees Celsius. Now we look at the units here, we have units kg power minus 1 and this is kg power 1. So when we multiply something like this, we add the powers. So minus 1, 1, we cancel them. And degree Celsius also, power minus 1 here and 1 there, so we cancel the Celsius as well, the degree Celsius as well. The only one left here is J, it's joule. So Q, joule. Q always with joule, okay? Okay, so Q is 2,520,000 joule. Okay, friends, thank you very much for watching. I hope you learned something good from this explanation, okay? I hope you learned something from this explanation. This is the way how we answer the questions, okay? For those who haven't subscribed for me yet, please do. And don't forget to press the like button. You may give your comments as well, okay? I need your support. I need your encouragement. Thank you very much. I'll see you in the next video.